Hello, this is Vels from Global Tutor. Now, we came across this problem on a forum. There was a question which was asked, a physics forum, and the problem was that a plank which is made of wood has a density of 0.7 grams per centimeter cubed. Now, that's the density of the wood that the plank is made of. Now, a hole is drilled in that wood, and then that hole is filled with a material that has a density of 2.5 grams per centimeter cubed. Now, you're then told that the plank then weighs 360 grams more than it did in the beginning, and the question is, what was the volume of the hole? And the person who asked the question was unsure as to how to get to the answer. The answer is meant to be 200 centimeters cubed. And so we'll just write that in there to remind us. And we'll see whether or not we can work this out so that we can get to the correct answer. So this scenario is drawn out over here. What we have is we have a plank of wood, and then a hole is drilled into it, and then it's filled with some material. So that ends up filled with some material, and that material has got a density of 2.5 grams per centimeter cubed. So in order to set up this question and the solution, I'm going to put in a couple of symbols. Let's say that the weight of the plank initially was W1, and that the weight of the plank in the end is W2. Now, what we really should be doing is should be talking about mass. So instead of having W1 and W2, we really should have M1 and M2. You see in the question, there's the use of the word weight and weighs, but really that should be mass. So M1 and M2. So the initial mass and the final mass. Now we've got two densities. We've got the density of the plank, and then we've got the density of the material, which the hole is filled with. So let's get right into it. So let the volume of the hole be V. So let's say volume of hole is equal to V, and that volume will be measured in centimeters cubed, because all of the information in this question where we're talking about volumes is in centimeters cubed, and we note that masses are in grams. So what can we do next? What we can do is we can write down the definition of density, and density is equal to mass over volume. Okay, so what we can say is when this hole is drilled, a certain amount of wood is removed from this plank. Okay, so the mass of wood removed will be given by the density of the wood multiplied by the volume which is removed. And so that's equal to the density of wood multiplied by the volume which is removed, which is V from there. And we can calculate that and put a figure there, because we know what the density of the wood is 0.7 grams per centimeter cubed, and then that's multiplied by V. So this is the mass of the wood that's removed. Okay, so 0.7 multiplied by V grams of wood is removed to make that hole. Right. Now, what we can do next is we can say the mass of the material added is equal to the density of the material multiplied by that volume, and that volume still is V, because the same volume of wood that was removed is the volume of material that's added. And so the mass of the material is then equal to the density of the material, which is 2.5 grams per centimeter cubed, multiplied by V. Okay, so then we now have the mass of the material which was added and the mass of the wood which was removed. In order to continue, I need a little bit more space on the board, so I'm going to remove the question itself. I think that we all know what the question is now. And we're going to write down a statement. And this statement is going to help us to understand the calculations themselves. We are told that at the end of all of this, the Planck has increased its mass by 360 grams. So if we take the final mass M2 and we subtract the initial mass M1, we should get an answer of 360. So we can write that M2 minus M1 is equal to 360. That is information that we're given in the question. And then we can write down an expression for the final mass M2. And that final mass M2 is equal to the initial mass M1, that's the initial mass of the Planck, minus the mass of the wood that's removed to make the hole. And the mass of the wood that's removed is 0.7 multiplied by the volume of that hole. And then we add the mass of the material which is added into the hole. And that's plus 2.5 multiplied by the volume of the hole. Looking at this equation, we can see that we could get M2 minus M1 if we take this M1 to the other side of the equal sign. So I'm going to go ahead and do that. And I'm going to get M2 minus M1 is equal to, I'm going to have minus 0.7 V plus 2.5 V, which I'm going to swap around to give me 2.5 V minus 0.7 V. And when I do that calculation, what I end up with is 2.5 minus 0.7, which is 1.8. So 1.8 V is the difference between M2 minus M1, which we know is 360. So 360 is equal to 1.8 V. Therefore, V is equal to 360 divided by 1.8, which gives us a nice clean answer of 200 centimeters cubed. So that's the solution to the problem. And really the only way to get to the solution is to start off by drawing diagrams and using those diagrams to understand the problem, then thinking through it. And when you think through it, you think, okay, we've got an initial mass for the Planck and a final mass. When I drill the hole, I remove some wood, so I've got to account for the mass of that wood that's removed. And then I fill the hole, I add some of this material, so I've got to account for the material which is added. And that's going to contribute to the difference in mass between the situation before and the situation after. And we see that the volume works out to 200 centimeters cubed. I hope that really helped. If you've seen this problem on the internet or in an exam or a question practice set of questions and you couldn't get to the answer, I hope that really has helped. If you enjoyed this, then please do click subscribe and subscribe to our channel. And keep checking back with our channel, The Global Tutor, because we are going to be making lots of these videos to help physics students all around the world to understand the coursework better. See you next time.